Good morning, everyone here in sunny Las Vegas and in the cloud watching us over the internet again. I would like to welcome you here in Las Vegas. As you may remember, last year we had 70% growth in attendance, and I'm excited that we are up again in attendance this year. And I'm very excited that we have a very international attendance here. The United States, as the host country, is certainly attended with the most people, but we have people coming from roughly 50, a bit above 50 countries here. So it's all about networking. Networking with global experts coming here with their expertise, but also with our people kind of giving you some news about our technologies. So it is about what is Leica Geosystems focusing on. As you know, Leica Geosystems measures the world around us. We have unlimited applications where our instruments and solutions are going in. It is in segments from infrastructure, infrastructure where you need concrete. Do you know that 60 to 70% of the concrete production is in the BRIC countries? So that gives you also kind of an idea where we have to focus in the future as well. It's resources that we use our resources efficiently in different applications, and that we make the world safer with our forensic applications and monitoring solutions in many, many applications. We do this in a two-speed world. In a two-speed world, the advanced world with a slower growing GDP, it's currently our bigger market. But we see fast growth in the emerging worlds, which is currently a smaller part of our business, but still significant. And we believe in the parity, that the parity is coming. So I believe that our business in the next decade will be half emerging market, half the advanced markets. And that means we need to understand what is needed in the advanced economies and also what is needed in the emerging economies. So in the advanced economies, it is all about efficiency everywhere. We need to drive to efficiency in everything which we're doing. In the emerging economies, is more growth is everywhere. So you can deal certain applications with good enough solutions, but efficiency is needed too. If not now, then tomorrow. And that's something where we need to think if we think about our solutions. So what we are doing is we are having in our strategy is that we will go local around the world. Going local around the world means that we have drive the solutions that drive the efficiency, and going local means that we go in these places where our customers are with local teams. Leica Geosystems has about 3,500 employees worldwide. And since quite some time, we are focusing on the BRIC countries. In China, we are there already since several years. In India, since 5 years, with local teams, highly competent. And over the last 8 months, we acquired our partners, long-term partners, in Russia, in Kazakhstan, in Brazil. And that means that now we have 25 our employees in the BRIC countries, helping us to bring our solution more local, localize them for the needs there. Driving with efficiency with innovative solutions. That's about kind of what we are doing here in the Geosystems track. We have organized 20 training classes, 120 sessions, and we try to organize them in 20 focus areas. And they are all organized in 3 subtracks. So we hope that you find the interesting part in one of these 3 subtracks. It's whether the 3D laser scanning or the high definition surveying track, the surveying infrastructure, construction and mining track. So this year we have the first time machine control representing here at our conference, and also the mining, and also the geospatial track. And in the zone, we show you real heavy material. And my team told me, Juergen, if you never have driven a dozer, you're not a real man. So they made me drive a dozer, they made me drive a grader and all these things. Unfortunately, we cannot let everyone drive who is not yet the man, so here on the show, but make sure when you have a chance, get on a dozer. What we want to do is, and this next session is about the world is not flat or static, and nor should be the map. And that's about the next 40, 45 minutes. We're invited 4 experts out of my group to speak about towards digital 3D worlds. 3D, because the world is not flat. Digital, because it's not static, and we need to make sure that we can make quick updates. And I would like to start to invite for the first session our expert, Rüdiger Wagner, who will speak about from reality to digital 3D cities in hours. Rudi, please come on stage.
Thank you very much. Good morning, everyone, and welcome. I'll speak to you over the next couple of minutes how we get from reality to digital 3D cities in hours. Or in other words, how do we go from 2D to 3D? Now, if we go back in time over the last 100 years, a lot has changed in airborne imaging. But the one thing that has been constant over the last couple of years is that Leica Geosystems has been at the forefront of leading-edge technologies. We've been pushing the boundaries of what's possible in airborne mapping today. So much so that last year we stood before you and we shared with you this slide. The Northwest Group engages in the North American Imagery Program, and last year, using our last year technology, they've acquired data over 2.3 million square kilometers in a period of 3 months. That's 23,000 square kilometers of orthophotos at 1 meter resolution per day. This year, using our latest technology, the Leica ADS-100, they're able to improve efficiency significantly. This year, we predict that Northwest Group will acquire the same area in a matter of 1 month, improving the area acquisition rate significantly or improving the resolution significantly. Now, if we look at what this data is used for, this is an example of New Mexico, and mainly NAPE data is used to monitor agricultural activity. Now, if you look at this data here as well from 2010 to 2012, you will see that the other purpose, monitoring change, is maybe not what you would call rapid change. Rapid change, as we've heard this morning, is happening in other areas. And we need to look to urban areas where we see rapid growth rates. Juergen Dold said this morning, we have urban areas growing by about 180,000 people per day. That's 2 people per second, and you can calculate how many people are moving into cities whilst I'm standing here talking to you. This is putting significant pressure onto people and resources, and also onto infrastructure. Now, orthophotos, as we've seen them classically, are still used widely to monitor change. If I can focus you on the highlighted areas, this is an example of the city of Zurich. You will see that this change in this very focused area is happening in a matter of weeks. And with orthophotos, we're able to highlight that change. But it is in these areas, these rapidly growing city areas, that we soon reach the limitations of what we are capable with 2-dimensional orthophotos. Why is that? Because the majority of cities are growing vertically. Maybe not so much in North America, where you have a lot of land available, but particularly in developing countries, average built-up area densities are increasing by the day. And again, we need to monitor that change. Or as Gerhard Schrotter from the city of Zurich says, monitoring this change and providing 3D information improves the lives of the people living in those urban areas. Now, we have a number of technologies available to highlight that change. Simplest, we use oblique viewing technology that supplements the nadir view and allows us to add a different perspective. This is an example of Prime Tower in Zurich, and you see various views that allow customers or users to measure, change, or make observation in these data sets. It's basically flat, but you get a different perspective. So the true power is naturally in 3D. And I'm very pleased to share with you that our latest technology, the 3D City Modeler, is able to combine stereo imagery, whether this is from airborne or from satellite data, with existing footprints that we have available in our cadasters. And out of those, we create point clouds in which we then can start to measure, in which we can segment and create real buildings and real models. As you can see here, these models are supplemented with oblique imagery and texturized to represent the real world. Many of you that are engaging in these kind of technologies may say, that's a cool idea. But what about if I don't have building footprints? And you know, this is a very, very valid question. Recent research, investing across borders, a database, has shown that only 23% of the countries in the world do have land information systems or land information available. So if you don't have land information, it's probably likely that you don't have building footprints. So your question would be absolutely valid. Well, I'm pleased to share with you that in Q3 we will be releasing the 3D Building Finder. And in this next animation, you will see that this technology allows us to take only imagery, stereo imagery from airborne or satellite data, and without any other additional information, we are able to extract buildings. In this case, we would then extract first a point cloud. In this point cloud, we would use technologies to measure roofs, to engage roofs, create the buildings, and then texture those buildings. This example that you see here was done in hours. The buildings are extracted out of the point cloud in seconds, so we may not be able to build Rome in a day, but certainly, as Juergen was saying this morning, we can build Zurich in a week. Now, the one thing that I want you to remember is that these 3D models are real objects. As the next animation will show, these real objects are inside our buildings or are inside our city model and are or can be edited manually. Each individual object can be moved around. We can assign values. We can assign information. And if we don't like the information or if we don't like what we see, we can simply delete the building and add a new one. Now, when we take these buildings, we can of course also take them out. And as you will see later here in this presentation today, we can assign other information to these buildings. This could be floor plans, these could be scans of any kind, or it could be other vital information that would help first emergency responders to make better decisions and to have better actionable intelligence. Now, these buildings, of course, change over time, and anyone who's living in a city knows that building areas change daily. And maybe you need updates on a relatively frequent time. Now, traditionally, it doesn't make much sense probably to fly these very local changing areas with traditional airborne sensing technologies. And I think for this case, I'd like to invite with me on stage our latest solution that we are able to provide to you in Q3, and I hope I'll raise your focus to the right side of the stage. The iBotics X6 is technology that you can employ locally. You can employ that to monitor infrastructure, to create a solution around monitoring a building, and we will, in a first step, employ monitoring solutions for infrastructure applications, and in a second step, we will work on creating photogrammetric solutions around those that will allow us to update those local buildings at survey-grade accuracy. That I will report to you the next year. And with that, I thank you very much for your attention.
Great presentation, Rudi. Thank you very much. It's exciting to see how the progress is done in building 3D cities, 60% faster autophotos, and we're looking forward to report about UAV technologies next year. Good. Thank you, Juan. Thank you, Rudi.
Thank you.
So, before we go to the next session, I know you're all managers and manage yourself, but I would like to remote control you for a second. When you came in, you got glasses, and I want to see whether you can operate them. Kind of. Okay, yeah, absolutely. You put it on your nose and look at this. So, not yet. You can take it off again. I just wanted to see whether you listen. So what it is when Stuart comes in, it's the next presenter. He will talk to us in managing roads in 3D at traffic speed. If you miss the glasses when he says you take it off, we will leave you in 2D world and you will not join us to the 3D world. Please welcome Stuart Woods, our expert on mobile mapping. Stuart.
Thank you, Juergen, and welcome, everyone. I want to talk to you today about something I'm very excited about. I'm very passionate about that. So let's get started, and let's go to the street level. Let's start off with some news facts. There's over 80 million stop signs in the United States today alone, right? If you heard back at the beginning of this morning, by 2040, there's going to be 65% of the population in the world is living in our urban cities, okay? If you remember back some of the numbers, this is 2 people per every second moving into our cities, okay? This is not just about stop signs anymore. It's bigger than stop signs. Every sign, every stoplight, every lane marking, every road barrier that you passed on your way here is an asset. Now, assets have to be tracked. And guess what? The requirements for these assets are getting tougher. Wouldn't it be easier if you could actually drive down the road with equipment that you already owned and capture those assets? Well, starting today, we're introducing the Leica Pegasus 1, and you can do just that. We're making your scanner mobile. Our solution here is vehicle independent. You basically fly in, 2 boxes, map, and fly out. It's that simple. From us, you get a complete solution from hardware to software in one package. At Leica Geosystems, it's not just about making your scanner mobile. We're beyond that now, okay? You heard that throughout the talks today. We're about extending the use of your equipment. We're about extending your business. And more than that, we're about making your business mobile. Now let me talk a little bit about the software that's included with the system. You navigate it visually and naturally. You have immediate access to the point cloud and the images together. They're calibrated. If you miss a shadow because of LiDAR, you can actually fill it in with photogrammetry. Okay? Now, I have an example for you from Zurich West. And if you would, please put on your 3D glasses. Okay, if you look over here in the left-hand side, you can actually see you navigate naturally, visually. And when you get to an object that you want to look at any point, you can actually click on it. And if you look over here at the right screen, you can actually immediately measure in 3D any access and any point that you want to look at. And you can see here the operator is simply measuring the distances of a tunnel, quite simply and straightforward. At any point, you have immediate access to add a GIS metadata to a point that you see in the city. This is about taking your 2D city 3D. Let me talk a little bit more about applications, right? So there are over almost 4 million miles of paved road in the United States today, right? In that, there are about 600,000 overpasses. Guess what? The majority of those are measured by crews today. We talked a lot about project planning today in the earlier opening session. Imagine if you didn't have to wait for verified clearances within a project. Imagine adding your own value in a project during a plant construction or for example, like a nuclear power plant deconstruction that's in the news today. Here with the Leica Geosystems Leica Pegasus 1, we take your scanner mobile, okay? So you can actually measure your clearances yourself, real time, within your project. What we're doing here is we're expanding your services. Imagine the opportunity for you to offer regular, updated emergency route planning because your scanner's already paid for. Remember, this system is vehicle independent, so you can also take it on railroads and measure vegetation clearances. Today, let's talk about another application. There's 80,000 advertising billboards lining the US highways today. This number is growing at 10,000 per year. And there's a law that actually allows a maximum allowable number of 10 million. Now, do you think if there's 10 million of anything, it's going to be compliant to the laws? These billboards are regulated, right? But unfortunately, in order to enforce those regulations, we need to know the distance from the road, and we need to know the size of the billboard. Now, with the Leica Pegasus 1, you can drive, process the data, and find revenue for our local states and cities, all with an ROI on yourselves. And this is all at vehicle speeds. This application is about funding our schools, our cities, and our neighborhoods. In 1939, GM spoke of a future where cars drove themselves. The other week, Mercedes introduced the first commercial car to do just that. Unfortunately, for Juergen, it's not at German highway speeds. But I promise you, it will soon happen. Our technology and our challenges today on our highways can no longer be done in a 2D world. Even our cars are operating in 3D on our highways. Right now, our roads, highways, and cities are evolving. 3D is no longer a luxury. It is a requirement. Here at Leica Geosystems, we're providing you the tools to gain ROI and move into a 3D world. We're creating the future today, and today starts tomorrow. If you'd like more information, we have a mobile mapping session during our Geospatial Solutions subtrack. Thank you.
Great presentation, Stuart. Thank you very much. I like your excitement for mobile mapping, and thank you. It's great to see. We have thousands of scanner users in the market, and those who have high-speed scanners can take now the new Leica Geosystems solutions to take their scanner mobile and expands your business. So what we have done now is we have looked how we map the cities from air, how to map the cities, the streets, from the street level at traffic speed. And it is now about buildings. Smarter ways making buildings, about BIM. And I would like to invite our expert, Kathy Hayes, to come on stage. Kathy, please come.
Juergen. And now let's talk about buildings, my favorite topic. The building construction industry is a $4 trillion industry globally, with massive growth projected over the next 10 years. Today in the industry, they're suffering from low productivity and high waste factors, largely due to rework. The complexity of buildings is increasing, as well as owner expectations to lower cost and increase quality and adopting new technologies. And as the economy recovers, contractors will have no choice but to revamp old antiquated processes to remain competitive in the marketplace. All of these factors are coming together, creating a perfect storm in the construction industry. So there's no better time to take advantage of the opportunity being created. breaking news. A wave of new processes and supporting technology has already transformed the design of buildings. And now, a second wave has started transforming the construction industry. This process is called BIM, or Building Information Modeling. BIM is a game-changing process where a building is designed as a virtual model with intelligent building components. With BIM, costly and wasteful rework is avoided, since the entire project team is working on one model. Constructability problems are identified much earlier in the process, resolving issues in the office so they never make it out to the field. The BIM benefits are clear to contractors, proven by the 74% adoption rate in North America. Now, this is an impressive number. However, BIM usually stops in the office. So there are lots of BIM benefits yet to be gained by bringing BIM to the field. There's good news. There are two strong BIM trends emerging on the job site: construction layout with total stations and as-built capture with scanners. What could be more exciting for Leica Geosystems? We already have the BIM solutions that the construction industry needs to make the transformation to BIM. Today, Leica's #1 global market-leading robotic total stations, scanners, and software provide BIM-based workflows for construction layout and as-built scanning. And now, I'd like to introduce the Leica BIM Field Trip, a solution that encompasses our scanners, robotic total stations, and software that naturally connects with the BIM process. The Leica BIM Field Trip is the answer for contractors to extend the value of BIM into the field. As-built information of existing buildings is captured with scanners to inform new construction, bringing the reality in the field to the model in the office. And new construction layout information from the office is projected out on the site using Leica total stations, replicating what's in the office directly in the field, bringing the model to the field, or physical construction. And then new construction in the field is captured using scanners or robotic total stations, so the office can validate that what was built is what was designed, bringing the reality in the field into the office. Leica solutions simply make BIM better. That by bridging the gap between what is actually in the field and what is virtually coordinated in the office, buildings get built right with less rework and more predictability. And at Leica, we do this better than anyone else with the fastest, most accurate instruments in the entire world. We make BIM better by capturing accurate as-built point clouds of existing buildings with our scanners. They inform models with reality, so new construction is based on what is actually in place today, improving the quality of designs and constructability, thus reducing rework due to inaccurate as-builts. The Beck Group had problems with inaccurate as-builts on the North Texas School of Law. This was making it impossible to create accurate designs and construction solutions. The answer? Beck used Leica P20 Scanner and Leica CloudWorks with Autodesk Revit. They quickly and accurately capture conditions after demolition to inform the renovation work. The new construction was planned within the point cloud, and this assured that everything was designed around the reality in the field. And the result? Less rework in the field, keeping the project on time and on schedule. Leica makes BIM better by accurately locating new construction with laser precision. Models are enriched with construction layout points. They get replicated in the field with total stations for faster, more accurate construction, thus reducing rework from things being built wrong. Holder Construction was struggling to increase accuracy and productivity with concrete layout of multi-story building projects, such as the CTEC project we see here. If the structure's not built correctly, then nothing else will fit as designed, creating a domino effect of problems in the field. On the CTEC project, Holder extended the accuracy of the model in the office into the field by enriching it with layout points that were replicated in the field using Leica total stations. Each and every point was located very accurately, creating paint-by-numbers installation for tradesmen. The result? faster, more accurate concrete layout, reducing labor cost and project time. According to Holder, Leica and BIM is a win-win combination. We'd like to hear that. Another example, Harder Mechanical, the mechanical contractor on the Linus Pauling Research Center. They struggled to coordinate process piping within the building envelope. Working in 2D simply did not provide the insight that they needed to get the job done. Solution? The building model was enriched with process piping using Intergraph CADWorks Plant Professional to assure the design would fit within the allotted spaces. Once the process piping design was complete, pipe spools and assemblies were fabricated directly from the 3D model, increasing accuracy and reducing rework. Leica makes BIM better by validating things were built right to reduce rework. As-built construction is captured with scanners or total stations to be compared with the model to find deviations that could cause problems with other systems yet to be installed. Solutions are created in the office so that they never make it out to the job site and turn into unexpected schedule and budget changes. At the Sutter Medical Center, despite having a highly coordinated model in the office, Ghafari struggled to coordinate the mechanical, electrical, and plumbing trades in the field. Changes in the concrete and steel structure during construction compromised or changed the spaces that were allotted for the building systems. Solution? Ghafari scanned the structure as it was being erected, merged the scan data with the model using CloudWorks for AutoCAD and MicroStation. This allowed Ghafari to quickly identify clashes or interferences, such as a steel beam that we see here that deviated from the design. The yellow line shows where the misplaced beam was actually located. And you can see that the mislocated beam is now going to cause a clash with this pre-assembled piece of piping yet to be installed. This very valuable insight allowed the project team to solve the problem digitally long before it became a schedule-halting problem in the field. As you can see, the Leica BIM field trip is a high-value solution for the construction industry. But what if contractors could have one total solution to complete the entire Leica BIM field trip? Newsflash, now Leica's making BIM even better than before. We're excited about the upcoming Nova MS50 multi-station launch, the BIM one-box solution that's Leica's newest innovation and the ultimate solution for the perfect storm happening in the construction industry. It's one single, easy-to-use solution that combines our market-leading scanning and total station technology with supporting software that naturally connects with BIM processes. The Nova MS50 is making BIM even better than before. If you're excited about construction's transformation to BIM, you can learn about what our customers are already doing today with BIM, with over 15 classes to choose from here at HxGNLIVE. The must-see class is BIM and Building Construction, the Leica BIM field trip, with Holder Construction featuring their success with BIM and Leica. Come join us in leading the BIM revolution. Thank you.
Great presentation, Kathy. Thank you very much. It's great to see how Leica Geosystems helps the 4 trillion market to be more efficient and also connecting with our instruments with the CutWorks from Intergraph, the BIM solution. Thank you very much, Kathy.
Thank you.
Good, great. So what we have seen in these 3 presentations is that it's about applications where we have to capture the real world and bring it into the design and capture the reality to make more out of this. And scanning is one of the key technology which we have basically created a scanning market over 10 years ago. And what I would like now is in the next session to focus on scanning. Scanning into the future with Fahim Khan. Fahim, please come on stage.
Good morning, everyone, and welcome once again. Scanning or high-definition surveying has come a really long way. And what I'd like to do in the next 10 minutes or so is to share with you some of the innovations we're bringing to the market, look at some of the benefits that our customers are enjoying, but most importantly, look at how everyone can get started with HDS today. To start, let's look at this drawing. This is a schematic representation of reality. This is the piece of information that we use to manage change in industrial facilities. Now, we can use this drawing, we can use multiple versions of multiple drawings to manage change in our facilities, or we can actually go and capture what is exactly out there last week, yesterday, the real world, and use this photorealistic representation to manage this change. And if you look at the video, you will see that not only can you view this information in a 2D static view, you can actually walk around this view, immerse yourself, and be able to better plan, communicate, and visualize this information to the different stakeholders. This is the promise of HDS, delivering to you high definition, accurate data, anytime, any place. Fusing the digital world with the real world. Now, if this was the year 1999, I'll proudly introduce to you the CIRA 2400, a system capable of measuring 800 points a second. It was a complete best-in-class technology at the time, reflectorless, by the way. But it was a system that required a laser scanner, a total station, a high-resolution camera, an operator, in fact, multiple operators, a generator to power everything, a truck to carry all the things to site, just a lot of skills and patience needed to get the job done. Fortunately, today is 2013, and you can certainly do more with less. We introduced to the market 6 months ago the ScanStation P20. The P20 has been a tremendous success. Thank you, everyone, for making this such a success. But this system is quite unique. Now we allow you to carry out the entire operation with a single person. We allow you to take advantage of the 1,000 times performance increase that this technology delivers versus older system. But what is most exciting about the technology is you can calibrate the system before you carry out high-precision scanning work. Now you can actually take on projects that you couldn't take on before. So this is quite a game changer. Today you can certainly do more with less. Not only can you do more with less, you can do more with less in many more markets. Get into new businesses, get into new segments, serve your customers with new deliverable, new applications, and so on. Over the next few days, you'll hear lots of different exciting applications of HDS in the areas of forensic, in public safety, in heritage, in plant and building. What I would like to do is to go through 3 quick examples on the use of this technology in the industrial context. First is what I would like to call smart retrofitting. Now, to support new environmental regulations, 77,000 marine vessels will have to install ballast water treatment systems. This has overnight created a $30 billion retrofitting industry. And increasingly, ship owners, shipbuilders are turning to HDS technology to capture the current condition, to document that facility, to help select the right ballast water treatment system, to help with space planning, to help eliminate rework, to help fabricate off-site instead of on-site because I have all the data. So this is truly a smarter way to carry out retrofitting exercise. We like to call this smart retrofitting. Second example is a synergistic product development between Leica Geosystems and Intergraph. This solution is Smart Plant Fusion, as you've heard earlier, and you'll hear a lot more about this over the event. But what it delivers to the asset owner is engineering information at their fingertips in a very intuitive, photorealistic user experience to support the analysis and extraction of information through that platform. So really a very simple way to fuse the real world with the digital world. We look at this as a smart way to carry out asset management. If you look at this next video, this is what I would like to say smart construction. Now, in the morning, you heard in Ola's presentation an excellent example of the French Revolution. This is probably the Korean Revolution. This is inside a shipyard in Korea. While there are international modularized construction activities that goes on, but just within a shipyard, within the construction of an individual ship, we are assembling hundreds of complex 3D blocks. And what we do is we can document this facility, we can validate this against design through HDS technology, through the multi-station, which is very well suited for this, and really fuse that compliance information at an early stage so that assembly operations can be forewarned of changes and so on. Certainly a smarter way to do construction work. So 3 quick examples. If you notice, all those 3 examples was centered around a single ship application. So imagine the infinite possibilities of this technology to serve your applications, to serve your industry. I personally enjoyed the most spending my time with police officers doing crime scenes. It's a fantastic experience. So I mentioned you can do more with less. It turns out you can do less and get more. I personally love to do less and get more. With a single push of a button, if you look at this video, you can actually see how we can very quickly document entire industrial facilities in minutes. Although it's a single push of a button, but what you expect from Leica Geosystems is the delivery of traceable, accurate, complete 3D information that you can depend on. So you press a button, but we do the engineering work to ensure that you get data that you can rely on, information that you can use to make critical decisions. So really certainly do less and get more. Now, all of this is only possible through the ability to capture information. And once you've captured information, not only can you do more with less, do more with less, you can also serve different disciplines with the same site visits that you've exercised. With a single data capture, you can serve the architectural community, the fabrication community, the construction management community, and so on. All of this is only really possible through solutions. And our view on solutions is that they come to life when we combine sensors with software, services, and support. We pride ourselves as your consultant for your application. Now, speaking of application, our view on application is that we should provide to you a sensor that supports your application need, a single database that allows you to fuse all of the different sensor information in one place so that you can share to multiple people, to multiple disciplines, and an application that supports that final business requirement. And it turns out that at Leica Geosystems, there are a number of applications that can support your business needs, be it for forensic, be it for heritage, be it for engineering, and so on. And in fact, we've extended this program to support third-party partners to build on top of our technology to meet your business needs. Today is quite an exciting day. We're introducing a number of new products, and what I would like to do is to share 3 new software releases that we are introducing to the market. First is Leica Multiworks. This product allows you to use your existing CAD skills, but to take advantage of high-definition survey data, 3D information, and be able to produce final deliverable through assisted feature modeling, through feature extraction tool. So this is really a perfect companion to the Leica Nova Multistation. The second example is Leica Infinity. This product extends your existing TPS, GNSS data processing workflows to support scan data post-processing on top of that. Allows you to process 3D information, 3D point cloud data, extract the deliverables that you need by combining all of the different sensor information. The third example is extremely exciting. This is Leica Geomos scanning. This is transformative. This transforms your survey technology into a monitoring solution. And it requires very little effort to transform that capability. All you have to do is to look through the live video stream of that multi-station technology, select the area of interest, press scan, and the system does the work. And you get real-time monitoring information, feedback to you, and you can make decisions accordingly. Not only that, you can combine scanning monitoring workflows with your existing GNSS, TPS, geotechnical sensor-based workflows to truly deliver a deformation monitoring solution to your customers. So this is really quite a game changer. You have to see it to really look at the capability of this technology. This static image doesn't do justice. So everything that you've seen is really a result of significant R&D made in software and in solution. And the perfect example of this R&D investment, if you like, is the Leica Nova MS50. I can truly say that this technology redefines HDS. Everyone can get into this technology of HDS without disrupting your workflows. Using your existing methodology, using your existing know-how, you can get into these new markets and new segments and do more with less. So with this, I would like to thank you for your time and invite you to join me on this 3D revolution to really take scanning technology from where we are today to new applications and new possibilities and beyond. Thank you very much.
Great presentation. I think you have demonstrated well how Leica Geosystems and we have redefined surveying with scanning technology. Thank you very much.
Thank you, Juergen.